Hello out there, and welcome back to Dinosaur Week at VINS. My name is Nathan, and I'm here to guide you through 250 million years of evolution that ultimately turned dinosaurs into birds. If you're unfamiliar with VINS, we are the Vermont Institute of Natural Science. We're a nonprofit nature center located in Quechee, Vermont, and we have a mission of motivating individuals and communities to care for the environment. We do that through education, research, and avian wildlife rehabilitation. Check out our website to see all that we're about, including, but not limited to, a busy bird hospital and a vast array of education initiatives throughout the state. Okay, let's go see some dinosaurs. This mobile represents part of the dinosaur tree of life. It's like a family tree, only instead of human relationships, like brother, sister, parents, aunts and uncles, grandparents, it shows how different species of dinosaurs were related to each other. The oldest dinosaurs, those that evolved first, are at the top, and the youngest dinosaurs, those that evolved latest, are at the bottom. Those dinosaurs that share a branch, like the Archaeopteryx and the Confuciusornis, are more closely related to each other than those dinosaurs that don't share a branch, like the Archaeopteryx and the Velociraptor. But this tree of life only depicts one group of dinosaurs, the Theropods, bipedal carnivores. It does not represent another well-known group of dinosaurs, the Sauropods, which were quadrupedal herbivores. The Theropods include well-known dinosaurs like the T-Rex, the Velociraptor, and the Archaeopteryx. The Sauropods include well-known dinosaurs like Brontosaurs and Brachiosaurs, and their evolution took a completely different path. So we're going to focus on the Theropods. Before we get too far into our journey through time, I want to go back and talk a little bit more about theropods. Earlier, I mentioned that theropods are bipedal and they're carnivores. Now, if you don't know, the word bipedal means walking on two legs, like a human. We are bipedal. A dog, though, is quadrupedal. They walk on four legs. A carnivore is a creature who only eats meat. No plants, no mushrooms, just meat. Theropods, though, had some other adaptations, and one of them that all theropods had was hollow bones. Yeah, so you thought that hollow bones were unique to birds, and you're right, they are. But the trait actually evolved in dinosaurs first. So modern birds, which evolved from theropods, also have hollow bones. This Archaeopteryx fossil was discovered in 1874, but it's only one of 12 similar specimens that were uncovered in the same general area in Germany. So who was Archaeopteryx? Archaeopteryx was a small, crow-sized dinosaur who lived near the equator at the time among coniferous tropical forests. And using sharp teeth and sharp talons, he hunted a bunch of little creatures among the trees. And its fossil was the first fossil uncovered that showed the world that there's a definitive link between dinosaurs and birds. Archaeopteryx was a transitional creature, caught somewhere between reptile and bird. Take a look at this fossil and note the long, bony tail, and it's hard to see, but a bunch of little sharp teeth, traits indicative of reptiles. But also note these feather impressions that surround the whole body, most notably the arms, forming wings. What you can't see in this specimen, though, is that the Archaeopteryx had a furcula, otherwise known as a wishbone. And feathers and wishbones are traits that we vehemently attribute to birds today. And don't forget, Archaeopteryx was a theropod, so it had hollow bones, just like modern birds. Now, over the last few decades, paleontologists have uncovered many new transitional fossils like the Archaeopteryx that help tell the story of the link between dinosaurs and birds. But Archaeopteryx was the first fossil that told that story, which makes it uniquely historical. Since we just mentioned historical a moment ago, I thought it was important for us to stop at this historical piece of artwork, the modern Velociraptor. Emphasis on modern. This clever girl, according to the movies, sported earthy-colored scales, stood about as tall as a human, and, working in a pack, could hunt down that human and eat them. But let's forget about Hollywood for a moment. The Velociraptor is actually pretty young as far as dinosaurs are concerned. They lived about 75 to 71 million years ago. And by that time, theropods had had at least 100 million years to evolve farther from reptiles and closer to birds. One of the later adaptations that the dinosaurs had evolved in this evolution was an elongated second talon, or claw. The Velociraptor used this elongated claw to hook into and subdue its prey, just like hawks and eagles do today. On the sweeter side, it's thought that the Velociraptor took great care to incubate its eggs, just like modern birds do. This would have made a coat of feathers invaluable, as feathers tend to be excellent insulators of heat. And while it's unlikely that the Velociraptor was a flighted dinosaur, evidence of feathers is clear. On at least one specimen, researchers recently found quill knobs along the arm bone of a Velociraptor. Quill knobs are little nodules in the bone where the feather was attached. So the earthy-colored scales of the Velociraptor were probably earthy-colored feathers. But one of the most poignant trends that persisted as dinosaurs evolved into birds was a gradual decrease in size. As paleontologists are uncovering more transitional fossils from later eras of dinosaur evolution, smaller body sizes are becoming more and more common. And the Velociraptor is one data point within that trend. But wait, isn't the Velociraptor like a 5-foot-tall super predator that hunted in packs? Well, yes, the Velociraptor did hunt in packs, and it was a super predator, but it wasn't 5 feet tall. It was closer to 2 or 3 feet tall. The Velociraptor from the movies, though, was based in some truth. In early attempts to place the Velociraptor on the dinosaur tree of life, some paleontologists lumped the Velociraptor with a related but different dinosaur called the Deinonychus. The Deinonychus looked a lot like the Velociraptor. It was closely related. It even had a very similar elongated second talon. It incubated its eggs just like the Velociraptor might have, and it may have even been a pack hunter. But it was like twice the size, much closer to the size of the movie Velociraptor. It's worth mentioning that our knowledge of the history of evolution from dinosaur to birds is still incomplete. We're learning new things every day, discovering new fossils every year, and what we think we know right now might be something entirely different in a decade. But for the things we do know, you can come and check out our Birds Are Dinosaurs exhibit here at VINS. There's so much more for you to discover, and even some things for you to interact with.